Hello, hello, hello. Emiliano, I'm kicking you out. Class is over. See you later. Hi, guys. Welcome. All my A names coming in hot. Good morning. Oh, good afternoon. Good afternoon. Hello, hello. Hi, everybody. Hey, hey, hey. It's so nice to see you guys' faces. You never get to see your faces. I love it. Hello, everybody. Jump on in. Jump on in. I'll go ahead and share my screen in a moment. Hope you guys are doing well. We're gonna have some fun today. I'm very excited. Okay. Dun, dun, dun. Hi, everybody. Welcome. Welcome, welcome. Thank you all for turning on your cameras. Just shoot me a private message if you cannot in the chat. Shoot me a private message. No big deal. Just let me know what's going on. Cool. Thanks for those private messages. I'm gonna go ahead and send you guys the attendance. Come on, work for me. There we go. Here's the attendance link if you need it. Go ahead and take attendance for me, please. Go ahead and take that attendance. We'll get started in about maybe 2 minutes. 2 minutes, 2 minutes. Good morning. Thanks, Galilee, for noticing. We have a question in the chat. Blow it up. Would you rather have pennies that match your height? We had a good conversation about what height means. Or would you rather, I'm sorry. Wow, I totally messed it up. Would you rather have pennies that match your weight or quarters to match your height? Pennies to match your weight, quarters to match your height. You can ask whatever questions you need to ask in the chat. You can explain why you're choosing that in the chat if you're just joining us. Ooh, seeing a lot of height. What if I told you that your quarters to match your height were actually measured in feet? So if you're 5 feet, you only get 5 quarters. I don't know. What do you think about that? Looks like a lot of people would choose height. Emma's changing her mind if we're measuring in feet. Weight. Yeah, it matters, right? Different things matter. Nice. If you're getting ready for class today, you need a paper, a pencil, hopefully your notebook if you're writing in your notebook, but I totally understand. Wow, Alan's doing some math over here. I love it. If you're just joining us, be sure to take attendance. Happy National Fajita Day for those of us who would like to celebrate National Fajita Day. Today's your day. Really excited. I love fajitas, so they are delicious. Also, it is David Lopez's birthday today, so if you know him, if you're friends with him, you can check in with him. You might really appreciate that. Cool. Yeah, good question, Gally. How would you like to measure the weight? What if we measured it in like milligrams? You'd be like a bajillionaire. That'd be pretty great. Okay, y'all. I think we're getting close to capacity here. We're at 33. We're gonna rock and roll. Yes, David, happy birthday. Super pumped. Okay, team, if you could please grab your paper and pencil. Also grab your assignment 2. Assignment 2. Your assignment 2, you can pull off of this page. You can grab assignment. I just want to bring to your attention, I try to make sure that like I post the notes. So if you want to see the notes, you can click this link. It'll take you to what the notes are going to look like. So you can either type, you can make a copy and type if you want, or you can just write them down on your own paper. So I'm down with whatever, however you want to take notes. I will let you go about that. Any questions before we jump into our notes for today? Any questions? Ready to rock it out? See some people opening that note section. Cool. You don't have to. I'm about to put it on my screen. So I'm going to switch over to my iPad here. Here we go. All right. So today we're going to talk about transformations. Transformations, does anybody know anything about transformations? Anything? Yeah, we've heard the word at least. Cool. So transformations essentially mean that we can like shift something up, we can shift a graph down, sideways, left, right, we can flip it over, we can stretch it out, all different kinds of things. So actually, I'm gonna go ahead and, so this is the table that I've like set up for us. I'm actually gonna not use my iPad, and I am going to show you on the screen so that we can use Desmos at the same time. So I'm gonna use this is really gonna test my Zoom capabilities, so we'll check it out. Okay, so if we're looking at the first thing, we have just a general graph of x squared. If I want to shift something up, if I want to shift up the graph, does anybody know what I actually do to the equation?
Wouldn't you try to subtract a value of y?
Yeah, I'm going to try to subtract a y value. Oh, go ahead, Scally.
It could be either or, just going up or down.
Yeah, so if this is like my general one, I'm going to add or subtract a number at the end. So if I subtract 2, the graph moves down. And if I add 2, you can see that the graph moves up. If I add 5, it moves farther up. If I subtract 1, it moves down, right? So in my notes today, I would say that in order to shift up, I would want to add a number right here, right? So add a number. So you could put the number 2, you could put the number sign, whatever you want to put there. And then we learned that if we want to shift down, we want to use the minus sign. So we're going to add them. We're going to put a minus number there, right? So that part there is how we shift up and down. There's also something called function notation. And function notation means that we have f of x. So let's say we have like f of x like this, and I'm going to say f of x equals x squared. If I want to move something up or down using that notation, I could say f of x. Yeah, now we have a blue one to mess with. If I add 2 on the outside, you guys see how it moves up 2 there? If I subtract 2, it goes ahead and moves down there like that. So the function notation version would be that on the outside of the f of x, I add 2 or I subtract 2. That would do the exact same thing of shifting up or shifting down. Mm-hmm. Any questions so far? Does this square with like what we already know? Yeah. Cool. All right. So, cool. So if I want to, the next thing I want to do is shift left and shift right. I'm going to assume that those are related. So if I have my general graph, does anyone know how I would shift the graph like left and right? How could I make it move left and right? Any idea?
Put the opposite value of x to whatever side you want to move to.
Yeah, but how would I where could I put a number, right? Like I have to put a number somewhere next to the x. Where could I put it? Kayla in the chat says put parentheses with x inside. Yeah, and then says adding or subtracting a number. So like something like this, right? So if I go ahead and put like -2 here, notice that when I put -2 here, it actually moves to the positive side. So it works in the opposite direction as what we would think. Remember, like positive, when we put +2 on the outside, it moved up, and -2, it moved down, right? That works kind of like normal. When we actually put something inside of the parentheses, it works in the opposite way, right? So if I want to move to the right, to the positive side, I actually have to put -2 on the inside of those parentheses. If I want to move to the other direction, to the left, I have to put a +2. So these work in the opposite direction. So when I'm thinking about my notes here, I'm going to put these parentheses in here like this. If I want to move to the left, which I'll just say is the negative side, I have a really hard time with left and right, so anybody with me, that's okay. If I want to move to the left side, to the negative side, then I'm going to put a positive number next to within those parentheses. If I want to move to the right, the positive side, then I'm going to go ahead and put those same parentheses in there, but I'm going to put -2 instead. Right? So if I want to move to the positive side, I put the negative number. So we notice these are like kind of funky there. So then using our function notation, knowing that f of x is x squared, how could I change f of x? Where could I put the +2 in order to move it to the negative side? Any ideas?
Could you repeat that question?
Yeah, thanks for asking. If I want to, so before when I had this one, I would put in here like this -2, right? And I have f of x, sorry. I want to put in, why can I not make this work? There we go. Okay, so I want the blue one to match the red one, right? I want it to match, but I want to use my function notation. So I want to take that green one and move it over to match the red one. If we put, let's say that we put a 2 here. See how it changes that way? If we put a +2, remember it goes up that way. Where could I put the 2 so that it moves over to match the red one? I could put it inside here like this to sort of match this exact same thing that I have here. Right, so I'm matching the same equation. So if I'm in my notes, I'm going to go ahead and put f of x +2. That would be the same as putting +2 inside the parentheses. The same for shifting right. I'm going to put a -2 on the inside of the parentheses. All right. The next two that I might think about are opening wider and getting more narrow. Right? So opening wider and getting more narrow. So if I want to, let me go ahead and clear this out. Just going to have x squared here. If I want to make it more narrow, I can put a number in front, like 2. If I put a bigger number, it gets even more narrow. If I put 500, it gets really, really, really narrow. So if this is my most basic one, in order to make it more narrow, I put a number in front. So for my notes, I'm going to go ahead, more narrow, put a number in front, like 5. If I want it to open wider, some people might think like, oh, I should just put a negative there. But notice that flips it upside down, right? So in order to make something more, to make it wider, I actually have to put a fraction. So like something like 1/2 would make it wider. The smaller the fraction, the bigger it's going to get. You can see if I put 90 here, it gets really, really, really flat. So I would say in order to open wider, I need to put a fraction. So I'm going to put like 1/2 like that. In our function notation, that looks like putting 1/2 in front here or putting 5 in front here, right? So we're multiplying that number. Okay. And then finally, we had a little bit of a clue here. In order to flip over the x-axis, right, in order to make something negative, we just put that negative in front. The same with our function notation, a negative in front and flip it over. Right. The last piece, the last like transformation that we might see is if we want to move, if we want to flip it like this, if we want to take, like, let's say, it's less exciting with a parabola, but let's say we have a graph like this and we want to flip it so the graph goes like this, then what we do is we put the negative inside like this, or the negative inside of the function notation. So let's say we were working with a graph of x to the third, and we put the negative in front here. It's going to take it and flip it over this way, something over here. If we instead put the negative in front, we create one where it goes like this, right? So it flips back and forth like this. Yeah. Cool. So we're going to mess with these a lot today. We're thinking about our transformations. For part of your assignment, you'll see something that looks like this, where you are naming what type of equation it is and then naming the transformations that are happening. So if you were going to think of like, what do I call this, right? Like what we were thinking about before, you would take this equation and you would say, okay, if I have this equation, but I only have the x's, right? I only have x. I'm going to go ahead and take out all the things that are related to the numbers. And I see like, oh, this is f of x is equal to the absolute value of x. That means that the name of this graph, as we learned last week, the name of this graph is absolute value. So the name of it would be absolute value. I remember that one looks like a V, looks like a V. Cool. Okay, and then it's going to ask us for the transformation. Ask us for the transformation. So I'm going to go ahead and think about the things that are happening to x here, right? So right now, right next to x, there's a +3. So that's like in the parentheses. So I'm going to go ahead and look at my notes. And I can see that when there's a number next to x, that means that we're shifting left that many, right? So the first transformation that I would say that's happening is shift left 3, right? That's what's happening right here. The next transformation that is like the next closest thing would be the 4, right? And the 4 is in front, it's being multiplied. So I'm going to look for one of these options that has a number in front. Like this one has a number in front here, as well as getting more narrow has a number in front. Which of those is the 4 doing? Is it a fraction, open wider, or getting more narrow, number 5, or adding the whole number 5? So this is the whole number 4. So this is getting more narrow by a factor of 4 in this case. So getting more narrow. Some people might say that that is like a condensing by factor of 4. And then finally, at the end here, we have a -2 on the outside, right? So -2 on the outside. I see that that is like this one, shifting down 2. So my last transformation would be shift down 2. So I dealt with the 3, I dealt with the 4, and I dealt with the -2. So that's how I would think about my transformations. All right. Go ahead and take a second. I want you to think about what the name would be for number 2. Go ahead and write down number 2. Give you a second to write down number 2. Once you're finished writing it down, go ahead and try naming it, and then take your hand at trying the transformations. Check that out. There are 3 transformations here. in about 30 seconds. I'm going to ask someone to share with us what they think the name might be. Anyone who wants to jump off mute and let us know what you think the name of this one would be.
Quadratic?
Yeah, try it. Go for it.
Wait.
Oh, I think you said the name and I thought you said I'll try it. But what did you say the name was?
Quadratic?
Quadratic, yeah. How did you come to that idea, David?
Because there's the x minus 2 and then it's being squared.
Yeah, the x is being squared. Absolutely. Awesome. Thanks, David. Happy birthday, by the way. So if I take this guy, right, and I just take out everything that is a number or that's related to it, right, then I end it, everything that is like just a numeric value except for that square, the last thing that I'm left with is the x is being squared. So that is definitely a quadratic. Cool. Cool. Does anybody have a transformation, one of the three transformations?
It's getting wider.
Flip over x-axis.
Okay, I'm going to go to Jonathan and then I'll go to Galilee. Jonathan, what did you say?
I said it's getting wider.
Getting wider, and by what factor is it getting wider?
By 1/3.
Perfect. Awesome. So since it was a fraction, it's getting wider. And then Galilee, what were you saying for the second one?
You flip it over the x-axis.
And what told you that?
The negative sign in front of the 1/3.
Yeah, the negative sign. Wow, it would help if I was able to spell negative. Thank you. Awesome. Okay, so we've dealt with the 1/2 and we've dealt with we've dealt with the negative and we've dealt with the 1/3. What would the last transformation be? Kimberly or Kimbo in the chat is saying shift right 2. And that is correct. Let me double check my left and right. Yes, that is correct. Because it's moving in the opposite direction. We're shifting right 2. There's a great question from, I think it's Jeanette. Is that how you say it, Jeanette? Janet. Okay, great. Awesome. Thank you. So Janet has a great question. Does it have to be in that order? No, it does not have to be in that order. These transformations could go in any order because if you are moving something left and right, or if you're flipping it over, they will always move in the same direction. I tend to, when I write them down, I tend to go from left to right just so I don't miss one. So in how I would write it is the negative would flip it over, and then the 1/3 would make it wider, and then the -2 would shift it to the positive side, to the right. Okay. I want to get your guys' opinion on how you're feeling today. If you could go ahead and give me a fist of 5. A 0, I don't get this at all. Like, this makes no sense to me. 1, I still have a lot of questions. All the way up to 5, I get this. Let me go. I'm ready to go. If you could go ahead and give me your answer. How are you feeling on this topic? Are you guys able to see the poll? I don't see anyone voting yet, so I'm wondering. Are you guys able to see the poll there?
Yes, the poll is visible.
The poll is visible. Did you guys vote? Vote. Guys, it's not letting me see anything. It just says 0 people have voted. Well, that is not helpful to me at all. Okay, I am going to create some breakout rooms for you guys to be able to work together. If you would like to work together, you can work in those breakout rooms. If you are like a 0 to 2, I would recommend that you stay with me and work through some of the assignment. I'm going to go through the assignment problems with you guys. If you want to go to breakout rooms, you can work with each other. If you want to stay with me, you can work with me during this time. If you want to work independently, that is totally fine. My one request is that our class is done at 2:50. At 2:45, I want to be able to like make any like end of class announcements. So at 2:45, I will pull the breakout rooms back. I'll pull independent people back, and we will all work together on those ones. Does that make sense? Any questions? Cool. Okay. I'm gonna go ahead and open up these breakout rooms. All right. If you'd like to head into your breakout room, you're welcome to. If you want to stay and work with me, you totally can. But you are welcome to move to those breakout rooms now, if you wish. All right. Hi, guys. Are you going to your breakout rooms or are you staying with me?
I think I'm gonna stay.
You're going to stay? Cool. You're going to stay. Ale, Kat, and Christine, are you guys back to work with me?
Yes.
Yeah. Christine, I've been noticing you've been freezing a little bit. Can you hear what I'm saying? Yeah, okay, cool. If you need to turn off your camera to save the Wi-Fi, that's okay too. Okay. Alejandra, are you there? I think maybe we will find out. Okay, team, let's work on the problems together. Do you guys have assignment 2 open? It should look like this guy. Yeah? All right, checking my chat. Alejandro, I'm sorry, your Wi-Fi is terrible. I hope you can hear me. Cool. Okay, let's work on assignment 2 together. So you can put in your picture of your notes later. Let's take a look at part A. So it says, given a description and a parent function, write an equation. So you can watch the video or read this to learn how to write equations in Google Docs, or I can show you as well. So I did the first like example problems for you, which is that they give you like a transformation and then you have to write the equation that goes with it. So for example, this one says that we need to flip it upside down and then we need to shift it down 1. So we can see that in the answer, it has the negative in order to flip it upside down. And then it's shifted down 1 by that -1 at the end there. Right? So that's moving down like this. Okay. So if I have a parent function of x to the 3rd, what I'm going to do is I click into the equation. Do you guys see how it like makes that little box around it? Right, so it makes this little box. It means that I'm going to write an equation. I want my equation tools to pop up. So what I'm going to do is press insert and then see how equation is like blurred out there. That's because I'm like currently in an equation. So I'm going to click to the outside of it and press insert and then equation. And then my equation tools will like pop up here. Right, so that's how I make an equation here. So I want to do x to the 3rd because it tells me a cubic function. So I'm going to do x to the 3rd like this. Right. Do you guys know how to make like the little exponent? You press shift 6, which is the little like caret like this. Shift 6. And then once you press shift 6, it'll make the little exponent. And then if anything that I type up there will be exponents. So then I just press the over key in order to get out of the exponent. So I have x to the 3rd. And then I want to flip it upside down. How can I flip it upside down? Brandon, I think you're muted.
Turning it to a negative?
Yeah, turn it to a negative. So right here in front of the x, I'm gonna put a negative sign there. Yeah, like that. Cool, good job. Okay, and then the other thing, it says shifted down 3. So how can I move it down? Like if it's now it's upside down, how can I move it down 3?
Subtract 3.
Yeah, subtract 3 at the end here. Right there. Subtract 3. Cool. Okay, so we did it. That's good. All right. So then for G, it says shifted left 3 and up 4. I'm gonna look at my example over here. So I can see that if I have a parabola and I want to move left 3, then I'm going to put that plus 3 on the inside of the parentheses. Right? And then if I want to move up 4, I put that 4 on the outside of the parentheses. So how would I go about starting this equation here? What would I start with? Kat, what are you thinking?
I don't know, Miss. This is
Yeah, it is hard. No, for sure. It is definitely hard. So start with your parent function. What's the parent function up here?
G parentheses x equals.
Oh, you tripped out. Your audio tripped out. But I think what you're going to say is x to the third, like this. Right? X to the third. Cool. Okay, so then shifting left to the left 3. So if I look at my notes, when it says shift left, I have to put this thing like a positive number inside of the parentheses. So over here, if I want to shift left, I'm going to go ahead and put those parentheses in like this. And then I want to do plus 3 like that. So we can see it's actually very similar to example B, or letter B. Right, and then I want to move up 4. So if I want to move up, I remember from my notes that I need to put the plus number at the end. So then this would be over here, like plus 4, like that. Cool. Okay, does that make sense so far? Yeah. Okay. Christine, are you still with us? How's your Wi-Fi? Still no bueno. Oh, still good. Okay. What should I do if I want to make it steeper or skinnier? What do they do for C?
They added 5 in front of the x.
Yeah, they put a 5 in front of the X. I think Christine was typing that. Add a number in front of the X. Yeah, thanks, Alejandra. Cool. Okay, so I'm going to put a 5 here, and then I'm going to put my parent function like this, x to the third. Cool. And then I want to shift it up 1. So I'm going to put that plus 1 at the end, like that. Right, so up and down, always at the end. Cool. Sweet. Okay, so every single time I'm going to start with my parent function, right? How do I shift right 5? What should I do? Plus 5. So right 5 would be, to the right would be the positive side. And remember when we put it in, we're going to put it in parentheses to move it left and right.
Negative if you want it right.
Yeah, negative because we want it right. So we're going to put -5 like this. So since we want to move it to the positive side, we have to put the negative there. It's really annoying. Miss Wall, who was our old geometry teacher before Mr. Welly, used to say, like, when you're in the house, you act a little crazy. When you're out of the house, you act normal. I don't know, like this thing she used to say. But she always used to say the parentheses were like inside the house. So when you're inside the house, you can act a little crazy. When you're outside the house, you act normal. So I don't know if that helps anyone else remember it. It's pretty silly. Okay, so we shifted up 5. How do we move up 2? What do we do?
You put +2.
We put +2 on the outside, right? So that's outside the house, that's outside the parentheses, so it acts normal. So if we want to move up, we move all up, right? Okay, and then we need 3 times flatter or fatter. So we need it to get wider. How do we make it get wider?
You put 1/3.
Ooh,
Right?
yeah, good job. Where do I get the 1/3 from?
Oh, because to make it wider, you need a fraction.
To make it wider, you need a fraction. Good job. So if we want it to be 3 times flatter or fatter, then we need 1/3. So actually, I need to go back and correct this. Thank you for correcting my answer here. This should be 1/3. Like that. Nice. 20s get fatter, use a fraction. All right, let's do J. I'm going to start with my parent function like that. Okay, how do I flip it upside down? Go, Brandon, go. How do I flip it upside down? Alejandro. Adding a negative. Yeah, Alejandro, good job. So we're flipping upside down, put a negative there. How do I shift it up? It says shift it up and left 3. So that's 2 transformations in there. We're going to shift it up 3 and left 3. So how could I do that?
Adding 3.
Adding 3. Yeah, do you want to add it? Where do you want to add it?
Inside the parentheses and outside.
Yeah, so adding it here, that'll move it left 3. And then adding it here, that'll move it up 3. Just like that. Cool. Okay, team. So you're going to do the same thing, but with the different parent functions here, right? So it's exactly the same. They should actually look very similar to each other. See how like these ones are actually like identical to each other, except for the exponents have changed, right? These are very similar to each other. These are very similar to each other, right? The only difference with these ones is that the instead of putting parentheses, you put the absolute value lines, like it's a group, so it works in the exact same way. You use the straight up and down lines instead of parentheses. Okay. Okay, let's try part B really fast so we know what we're doing here. Okay. Let's try number 1. So looking at the example, we're going to name the function just like we did in our notes, and then we're going to say what the transformation is. Okay, so looking at number 1, I see that if I took away this 4 and I took away the +2, I would just have square root of x. So I would say that this is named the square root function, or some people call it the radical function. So that's the name of it. And then the transformation, I'm going to start at the beginning. What is the 4 going to do? What's that number 4 in front going to do? Any ideas? The 4, if I'm looking at my notes, there's a number in front. So if a number is in front, it's going to get more narrow by a factor of 4 instead of 5 this time. So in this case, I would say that it gets more narrow by 4, right? Or by 4 times, right? It's going to get skinnier, okay? And then the +2, right? That's inside the house, right? That's like inside parentheses because it's inside the square root here. So if I look here, if it's a positive number inside the parentheses, that's shifting left, right? So I'm going to go ahead and go here and say that it's shifted left, and the number is 2. So I'm going to put 2. Shifted left 2. Okay. So if I'm looking at number 2 here, it's gonna, I have like x to the third. The 3 is the thing that's most powerful, so I'd call that a cubic function. Cubic. That's the one that looks like this, like a little like that. And then my transformations, I have the -1. So it's inside the house, acts a little crazy. So it's going to be the opposite. So it's going to move +1, right? So moving to the right. Whoa, that's going to mess that up. It's going to shift right 1. And then the -4 is on the outside. That's the thing that moves up and down. So then the -4 would move down 4. Good job, Christine. Down 4. Cool. All right, team. I'm going to pull everybody back from their breakout rooms. Do we have any questions before people come back? Doing okay? Okay, cool. Was that helpful, people who were with me?
Yeah, it was helpful.
Okay, cool. I'll also be back at 3:50 so we can do more. Awesome. Thanks, Alejandra. Okay, hi guys, welcome back. I hope that you were able to work in your groups. That is the end of our class for, well, we're ending class here for today. Your assignment 2 is due today at 11:59. So if you need any support with that, you can send me a text, an email, or my office hours are back here at 3:50. So if you have a quick question or we want to do some problems together, totally can answer them. If you have any specific questions, please let me know. I can make a video and send it out to you on a question or whatever. So please let me know if you needed any help. Other than that, if you have a question, you can stick around and ask it right now. If you are good to go, then you guys can head out and I will see you on Thursday. See you guys. Adios, adios. Bye.
Bye, Miss. Enjoy your day.
Bye, Gary. You too. Bye, guys. Bye. See you later. Thanks, Brandon. I'll see you later. Bye, guys. See you. Caitlin and Mia, are you guys frozen? I think Caitlin's frozen.
Oh no, sorry, my spy.
Bye. Caitlin, I think you're frozen. Can you hear me? Oh, there we go. Okay, bye guys.